We will be discussing the dietary reference intakes. You have very likely gone over each of these in previous classes and are familiar with the DRIs. However, I did want to go over some main characteristics of each so that we're all on the same page going into the semester. The DRIs, as you know, include the EAR, RDA, AI, and UL. We'll be outlining and defining each of these. However, I did want to go over the origination of the DRIs and where they come from. So just for you to think about before we move on to the next slide, who creates the dietary reference intake? What professional organization or board or committee has come together to create the DRI. So maybe take a moment to think about that before we move on to the next slide. All right, so often when I ask students in class, there are a number of guesses in terms of who creates and develops the DRIs. So we get anything from the FDA to the USDA, among other organizations. However, the dietary reference intakes were and are continually updated by the Institute of Medicine, what's called the Food and Nutrition Board. So the Food and Nutrition Board of the IOM is a committee of experts that have been designated to work together to create these DRIs for each nutrient. There are a number of resources for the DRIs online, and also in your text you can see the DRI tables. Here is the link to the DRI tables on the USDA website. So it's very clear and laid out. Not only do they have the DRI tables, which are very straightforward, but they also have all of the DRI reports. The DRI reports are very interesting, and they go over different categories of nutrients, how their kind of intake levels were developed, the justification for the EAR, the RDA, considerations for each nutrient. They're extensive reports, but you can go through each of these if you are curious to learn more. There is also on this website an interactive DRI tool for professionals, and you can see the link there. This DRI tool is very easy to use. You will intake or input the characteristics for the individual that you're working with. You put in their gender, their height, their weight, their age group, a number of other indicators, and then you select which nutrients you would like the DRIs for, and you'll get a full printout or report for that individual or patient that you're working with. So that's some neat resources that we have online. All right, so the DRIs here, they're separated into 4 different categories. With the EAR, the estimated average requirement. We have the recommended dietary allowance, or RDA. The AI, adequate intake, and then the UL, which is the tolerable upper intake level. I would like you to pause now and just think about what are some key differences between these, what have you learned about these nutrients, and what questions do you have? So again, pause, we can think about this, and then we're going to provide the definitions. Okay, so here we have the definitions. I'm going to provide a summary of each. You can definitely read word for word the definitions, but I do want to just highlight the key points of each. We'll first go over the estimated average requirement, or the EAR here. It's the recommended nutrient intake level estimated to meet the needs for approximately half of the population within a given gender and age group, or gender and life stage group. So the estimated intake level that is estimated to meet the needs of about 50% of the population. One thing that is unique about the EAR, and we're going to see this is similar to the RDA, this estimated intake level is based on an accumulation of evidence from the literature. So it is necessary to set an EAR to have, it's important that there is evidence, justification, and support from the literature that this is the level meeting the needs of half the population, given different epidemiologic studies and deficiency reports, research from actual evidence in real populations or individuals. So the EAR must be based on significant evidence. The RDA is going to be set at a higher level than the EAR. It's actually 2 standard deviations above the EAR. And if you are familiar with statistics, which I think a number of you are now because you had statistics class in the fall and have had other statistics classes, but if the EAR, if you're considering a normal distribution, is set at 50%, 2 standard deviations above that is going to then cover 97.5% to 98% of the population. So that's where the RDA is set at. So it's the average amount estimated to meet the needs of approximately 98% of the population in a particular gender and life stage group. The AI can be seen as comparable to the RDA in that it's the recommended intake level estimated to meet the needs of most individuals in a given gender and life stage group. However, it's used when an EAR or an RDA, which is developed from the EAR, cannot be determined. So this is for nutrients that we do not have significant evidence. And so this is based on expert opinion or experienced researchers in the field who have a degree of familiarity with each nutrient that can make a very educated, observed approximation of what would be the need for that specific gender and life stage group. We then have the tolerable upper intake level, and this is specifically the highest average daily nutrient intake level likely to pose no risk of adverse health effects. So if someone consumes an amount on average at the level of the UL, there is no evidence to suggest that there would be any risk of toxicity at this level. Once you go above the UL, then your risk of toxicity gradually will increase. I think there is sometimes a level of misunderstanding of the UL that this is the toxic level, or if you have this high level, then you are going to develop a toxicity symptom. But this is basically the highest safe level. Once you go beyond that level, your risk of toxicity will gradually get higher and higher and higher. This is a nice schematic or diagram of each of the DRIs. We can see here the EAR, the RDA, and the UL. And on each of these axes, we have this y-axis here, and then this x-axis is the observed level of intake of a given nutrient given from low to high. And then here we have risk of inadequacy or deficiency. Here we have risk of toxicity. So as we mentioned, kind of the safe level would be between the RDA and the UL. So a level above the UL, we see the risk of toxicity will gradually increase. And then below the RDA, the risk of deficiency gradually increases. So a level between the RDA and the UL would be considered a less risky level of intake, that we would have a low risk of both inadequacy and also a lower risk of adverse events due to toxicity. This is also another schematic or diagram. Often individuals have a more basic understanding of our needs and how it relates to our risk. So you can see here a more naive or basic understanding would be, anything below the RDA would be dangerous for anyone. Anything above the RDA would be safe, and that's enough. As long as you're having the RDA or above, you're going to be meeting your needs. So based on each of the DRIs and our understanding, that's more of a naive view. When we have the level of the RDA here, our risk of deficiency will gradually increase. So there's going to be first a marginal risk of deficiency and then a higher danger or risk of deficiency, especially as we go below the EAR. And then going above the RDA, especially once we get above the UL, we have this risk of toxicity that gets higher and higher as we get beyond the UL level. Just to emphasize again, we have the EAR and the RDA, with the RDA being 2 standard deviations above the EAR. And this is a nice schematic of individuals and their risk of deficiency and their needs and how that relates to the DRIs. So the RDA is a level estimated to meet the needs of 98% of the population, which means that a number of individuals may need an amount of a given nutrient that would be much lower than the RDA. So this table here outlines 3 individuals, person A, B, and C, and they're given needs for a nutrient. So we have nutrient X. Person A needs about 40 units per day. Person B needs about 35 units per day. Person C needs about 56 or 57 units per day. So when we're talking about the DRIs, actually person A and B, if they consume at least the EAR level, they will meet their needs. But if the person C consumes the EAR level, that is not going to be enough. So when we use the RDA and this kind of more general recommendation, this is going to be a safe level that is going to meet the needs of most everybody. We don't set it at a level that would meet the needs of 100% of the population, because that would be much higher, and that may start reaching a more dangerous level for someone like person B that doesn't need nearly as much. So this was kind of this compromise level of the 2 standard deviations above the EAR. All right, so I'd just like to make a few remaining points about the DRIs, specifically the RDA and the EAR. It's important to keep in mind that the DRIs apply to healthy individuals without any clinical populations or other special needs. So those with a clinical condition or a special population, their intake level and their needs may be higher or lower than what would be indicated in the DRIs. The RDA is generous, as we talked about, covering 98% of the population, so meeting most everyone's need. And this is regarding our usual or average intake, not necessarily our intake on any given day. One day we may go over the UL, we may go below the EAR, but this is going to be covering average or routine intakes. The RDA is important to keep in mind as it relates to intake sufficiency for individuals. So when making recommendations, you recommend an RDA level for a specific person based on their gender and life stage. The EAR, however, is used to assess intake status of groups. So we see the EAR used and reported in epidemiologic research and epidemiologic studies to determine if a given group or population is meeting their needs or getting enough in terms of their intake for a specific nutrient. So that is important to keep in mind when assessing the intake level for an individual. We use the RDA. For groups, we use the EAR. It will be important to keep in mind these important points that we went over regarding the DRIs. I will be mentioning the RDA or the AI for most nutrients, if not all nutrients, that we'll be covering throughout the semester. Those nutrients with a UL, so not every nutrient has a UL, but those nutrients with a UL, I will be providing that. And I would like you to note which nutrients have a UL, which nutrients have an RDA, which have an AI. It will be important to kind of keep in mind which of the vitamins and minerals have more research, thus to justify an EAR and an RDA, which nutrients do have risk of toxicity, therefore having this UL designation. So please keep this in mind as we go through our micronutrients throughout the semester, and we may be bringing this up for our application activities or discussions in class.